Our universe is vast. It's so vast that it's almost impossible to comprehend. Imagine traveling at the speed of light, the fastest speed there is. Even at that speed, it would take you 93 billion years to cross from one end of the observable universe to the other. That's a journey spanning billions upon billions of miles. And within this unimaginable expanse, a story of creation, evolution, and wonder unfolds. Understanding the universe's journey is like reading the greatest story ever told. It's a story that stretches back billions of years, to a time before stars and galaxies, to an era when the universe was young and full of energy. By studying the universe, we're essentially looking back in time, observing the echoes of these ancient events. This allows us to piece together the history of the cosmos and our place within it. But this story is not always easy to read. The universe is a complex and mysterious place, and scientists face many challenges in trying to understand its origins and evolution. One of the biggest challenges is the sheer scale of the universe. The distances involved are so vast and the timescale so long that it can be difficult to wrap our minds around them. The prevailing scientific theory for the origin of the universe is the Big Bang. Imagine, if you will, all the matter and energy of the universe compressed into a point smaller than an atom. Then, about 13.8 billion years ago, this point began to expand rapidly in a hot, dense explosion, the Big Bang. This wasn't an explosion like a bomb going off in space, but rather an expansion of space itself, carrying everything with it. In the first few fractions of a second after the Big Bang, the universe was an incredibly hot, dense soup of elementary particles. As the universe expanded and cooled, these particles began to combine, forming protons and neutrons, the building blocks of atoms. This era, known as the primordial nucleosynthesis, lasted for just a few minutes but was crucial in determining the future composition of the universe. As the universe continued to expand and cool, the first atoms formed, primarily hydrogen and helium, the simplest and most abundant elements in the universe. These atoms, scattered throughout the vast expanse of space, would eventually provide the raw material for the formation of stars, galaxies, and everything we see around us today. Scientists face many challenges in trying to understand the universe's origins. One of the biggest is the sheer scale of the universe. The distances involved are so vast and the timescale so long that it can be difficult to wrap our minds around them. Imagine trying to understand the history of the Earth if you could only study a single grain of sand. Another challenge is that we can only observe the universe from our limited vantage point on Earth. It's like trying to understand the entire plot of a movie by watching just a few frames. We have to rely on telescopes and other instruments to gather information about distant objects, and this data can be incomplete or difficult to interpret. Despite these challenges, scientists have made remarkable progress in understanding the universe. Through careful observation and theoretical modeling, we've been able to piece together a remarkably detailed picture of the universe's history, from the Big Bang to the present day. And as we continue to explore the cosmos, we can expect to make even more exciting discoveries in the years to come. Section 4. From Chaos to Order. A universe unfolds. Over millions of years, gravity began to draw the hydrogen and helium atoms together into giant clouds of gas. These clouds, denser and more massive than anything we can imagine, became the birthplaces of the first stars. Within these stellar nurseries, gravity compressed the gas, heating it to millions of degrees. This intense heat and pressure triggered nuclear fusion, the process that powers stars, fusing hydrogen atoms into helium and releasing tremendous amounts of energy. The first stars were massive and short-lived, burning brightly for a few million years before exploding as supernovae. These explosions scattered heavy elements forged in the cores of stars throughout the cosmos. These elements, essential for the formation of planets and life itself, enriched the surrounding gas, paving the way for the next generation of stars and galaxies. Over billions of years, gravity continued to shape the universe, drawing galaxies together into clusters and superclusters, forming the vast cosmic web we observe today. Within these galaxies, new stars were born, lived out their lives and died, each generation contributing to the growing complexity of the cosmos. Section 5. Our place in the cosmic tapestry. The story of the universe is not just about distant galaxies and cosmic events, it's also the story of our own origins. The atoms that make up our bodies, the Earth, and everything we see around us were forged in the hearts of stars that lived and died billions of years ago. We are literally made of star stuff. Understanding the universe's journey is not just an academic pursuit, it's a journey of self-discovery. By studying the cosmos, we gain a deeper appreciation for our place in the grand scheme of things. We are part of this unfolding story, connected to every other star and galaxy by the fabric of space-time. What mysteries does the universe still hold? What new wonders will we uncover as we continue to explore the cosmos? I encourage you to share your thoughts and continue to explore the universe around us. There is still so much to learn and discover.